Hello, everybody, and welcome. My name is Gabriel René. I'm the CEO of Versus. I'm also the Executive Director of the Spatial Web Foundation. And today I'm going to walk you through a presentation on the spatial web. So the spatial web has been described as the next era of computing. Deloitte put out a report in 2020 that walks through the broad strokes of what the spatial web means. They boil it down to the integration of the digital and physical worlds. But I'm going to take you through a much more detailed perspective of the spatial web today. So it begins with this usual suspects of emerging modern technology. Names and terms you've heard of that seem to be unrelated, except that they're all occurring in the same era. Virtual reality and artificial intelligence and Internet of Things and 5G and crypto and data rights and blockchain and quantum computing. These are all separate technologies, but they're all emerging around the same time. If you boil it down, there's really four major trends that these fit into. So those trends are essentially immersive computing, which is augmented and virtual reality. There's physical computing, which you can think of as the Internet of Things, it's various sensors and cameras and devices, and robotics, autonomous vehicles, etc. There's cognitive computing, which is artificial intelligence and machine learning. And then there's distributed computing, which is more about computing moving from the cloud to the edge, happening on devices. On robotic systems, the autonomous vehicles need to be able to compute in real time. They can't go to the cloud and ask whether or not they should hit the brakes. And distributed ledgers. Blockchains also are distributed computing. So these four major trends, though, really about a single meta trend. And that is computing moving into the space around us, right? Whether that's holographic or immersive information, where we're moving into virtual worlds or virtual content, overlaying physical objects in the real world, physical computing itself, all these various sensors and robotics that are making sense and tracking activities in the world, whether this is a temperature sensor, a Nest device, or this is an AI-powered drone, it's sort of part of the same thing. AI and cognitive computing, increasingly about using information about the real world and having what we call even AI at the edge, and what's called federated computing, where those artificial intelligence agents and capabilities are happening in those distributed computing environments. So distributed, immersive, spatial, ambient computing, you may have heard of these various different terms. They're all really talking about spatial, or some sort of spatial computing, right? The other lens to look through is the lens of eras. We talked about all those various technologies, and you can fit them into those four major trend buckets. There are other perspectives really on these technologies. So there's what's called the Human 2.0 lens. This has everything to do with digital health and well-being and CRISPR and genomics editing, and even the role of humans and interfacing with artificial intelligence, like things like Elon Musk's company Neuralink, which is going to have the brain become the interface to technology. There's the Society 5.0 lens, which is really about the different ages of human societies. And the Japanese have emerged with this narrative around what they call the smart society. There's the Industry 4.0 lens, which is predominantly around automation and robotic systems, advanced technological systems in our sort of industrial and enterprise environments. And then there's the Web 3.0 or Web 3 narrative, which is kind of at the intersection of being able to use computing systems to, in a trustworthy way, execute certain activities, as well as, many of us would argue, it's about that being multidimensional. So in kind of this intersection of metaverse type narratives. So taking that step back, what everyone is really interested in is not just that these technologies are powerful in and of themselves. They're all exponential in the sense that they have incredible power, but the convergence of these emerging exponential technologies and being able to use them together is really what this whole era is about. And the outcomes and goals and applications that we're looking for have to do with the relationship with these various different types of technologies. So you can think of this through a lens of several perspectives. This is called integral theory. Integral theory basically says there are four major perspectives on any one thing at any given time. So we kind of take that bucket of buzzword salad and we put it here in our bowl in the middle. You can have an individual perspective that is an interior perspective. So this would be kind of more about, if I told you I'm in love, well, I can't prove that. That's a very, what do you call it, a subjective perspective on these technologies. That's an individual interior perspective. There's an individual exterior perspective, this would be an objective perspective. So if I was talking about love, you might say, Gabriel, this is just chemical reactions in your brain. So there's two different perspectives on the sort of same event. In the bottom left, you've got a collective interior perspective. This is like the area of culture and value. So maybe a religious perspective on love. And then there could be an external collective perspective, which we consider an interobjective perspective, more of a systems theory point of view. We might talk about the result of what happens when different characters or beings or people fall in love, essentially to produce more mammals at scale. And so when we take the thing in the middle and replace it, love, with this sort of pool of emerging technology, an individual exterior perspective or objective perspective around that is the perspective of the Human 2.0 folks. They see those technologies through the lens of advancing human biology, human intelligence, human health and well-being. If you look at those technologies through an individual interior perspective, more of the experiential perspective, then that's a metaverse perspective, right? It's really saying, hey, what is the experiential view of that? So I'm interested in all these technologies, but more about how I experience entertainment or education or environment or travel or whatever. Only the Industry 4.0 perspective looks at this through the lens of productivity and optimization and what we call autonomous systems. And then finally, there's a Society 5.0 perspective as well. All these perspectives are equally valid, right? They are valid unto themselves, and they are also collapsible into each other, but they're not reducible. You cannot reduce a subjective perspective to an objective perspective. And so what's powerful about this is that these various different views are sector or industry perspectives on the relationship of these technologies. They would all like to be able to use Internet of Things and artificial intelligence and 5G and holographic data set and even robotic systems in some cases and or blockchain for certain things. But their perspectives on those are quite different. And there's different books and theories and groups and forums driving around these various narratives. So those are these four perspectives on emerging technology. Now, what we would really like, and what I mentioned at the beginning, is we would like to network these various technologies. What that means is we'd like them all to be able to work together. We'd like to compose different combinations. And in fact, the applications that each of those different sector perspectives on these technologies are taking is really about how they can use them for the applications that are relevant to them. Our argument is that the spatial web enables the networking, the interoperability of these various different technologies, and that these different lenses are just sub perspectives on a network that would serve all of them. And so the spatial web actually enables the internetworking of these emerging technologies that can power all of the various applications that these different sectors are looking for with respect to the way that they combine technologies to get the kind of applications that they're looking for. And so this is in part why Deloitte is calling this the next era of computing. It's why it's so consequential, because once you have a standardized approach to making those different technologies work together, you can essentially get what are called network effects, where there's scalable benefits and scalable value for all the participants in that network. So at Versus, we developed some of those core, what we call standards. These are standard ways of enabling these technologies to be interoperable, enabling them to be governable. And we donated that early research and development to our own Spatial Web Foundation. So we created a nonprofit, and it has many of Versus' original members. And we started to develop these standards. It was critical to be able to do this because the World Wide Web Foundation today, which is a nonprofit organization that developed and standardize all of the World Wide Web standards that we've been relying on for the last 30 years or so. That's a really critical piece in order to enable really free market opportunities on top of it, but not to have a competitive base. We started developing this core standard. We partnered with the IEEE. The IEEE is one of the largest standards bodies in the world, hundreds of thousands of engineers and scientists from every country collaborating for over 100 years on first everything electrical, and then everything electronic, and then all the way to the network, the large network scale computing that we do today. So Wi-Fi is an IEEE standard. And so every manufacturer in the world knows they can develop something that's going to be certified and reliable. Ethernet, 95% of all the activities we do today on the web, on the internet, go over IEEE standards. So we developed the Spatial Web Protocol Architecture and Governance Working Group. With them, we donated the IP, which was the specifications, the white paper, as some have said, but the documentation for how to enable this level of interoperability. And that's been declared a public imperative by the IEEE. It's their highest designation. It's because they recognize the importance of enabling the kinds of outcomes that we talked about for these various sectors, and why interoperability and governance over data and devices and content becomes so critical in this next era. So just to walk you through this in a bit of going backwards to go forwards, when the web first came out, we had web domains. We're all familiar with how that works. HTML was a way to program, lay out information on a page. And HTTP protocol allowed us to link and connect those various pages and sort of teleport between them, if you will. And one last point, which is that the web itself was designed as a stateless system. And what that means is that the states, the activities that happen when you were surfing the World Wide Web, don't get captured in the web in any way. They actually get captured by the companies that we use that intermediate our access to the web, like any of the browser companies. So if you use Safari, or you use Chrome, or you use Microsoft Explorer back in the day, and so on and so forth, or the various apps that we use, they're capturing those states. And what we call that today is data. And they've monetized that data in powerful ways and built multi-trillion-dollar businesses on top of that. In the era of the spatial web, the addresses for locations we call spatial domains. These are three-dimensional, or can be three-dimensional locations, instead of just addresses for pages, right? And the way that we program information is what we call HSML. Instead of hypertext markup language, which is the method we use for websites, it's hyperspace modeling language. It's a way of modeling the objects and environment in a room, in a space, in a way that is very standardized. And then there's HSTP as the protocol. It's Hyperspace Transaction Protocol. And actually it's stateful, meaning that the states of the spatial web can be captured and even owned and controlled by the individuals that are generating those. So this goes kind of back to your data, your privacy, and your ability to own it, control it, monetize it, are built in as a first-class citizen, as opposed to an afterthought that right now we're in a bit of a battle for in the Web 2.0 era. So starting with those new kinds of addresses, spatial domains. So here you can see an example of a city. You've got different locations, in this case rectangular, but they can be any shape. You can have locations in locations, so they're nested, right? It's a Russian doll effect, if you will. And this allows you to enable permissioning around what IoT devices or robots or drones or holographic content, where it can or cannot appear, what it can and cannot do. Essentially control that in the same way that on my website, my web domain, I can control whether you come and just read information, or I need you to log in order to access something, or in order to comment, or in order to purchase. And so similar concepts, but applied now to multi-dimensional spaces. And really the big difference here is the spatial web is not just a web of documents, a web of pages, which is what the World Wide Web is. It's a web of spaces. And these spaces can be physical spaces, virtual overlays over physical spaces. They can also be completely virtual spaces. And we talk about the popular concept of the metaverse, which has emerged in the last 12 months as a potential multi-trillion-dollar sector unto itself, which is why we're representing it in that sort of Web 3.0 metaverse lens. This applies equally. So what you can and cannot do, and how you would move objects and users between this sort of web of spaces, is just a subset of the metaverse, is just a subset of the spatial web. We talked about programming hyperspace modeling language. What that does is essentially describes the context of any situation, right? So any class of user, object, policy, activity in physical, digital, or virtual space. Essentially have categories of who's and what's, categories of what's and how's, how you can do what, and where and when, so across different dimensions, including space and time. That reality example there is so that you can have different rules and different policies for different reality. In the physical reality that we exist in today, Los Angeles and the state, the county, the city, the state, the government, the federal government may have certain policies as it relates to autonomous vehicles or artificial intelligence having access to certain data sets, or facial recognition cameras that can or cannot be turned on in certain situations that may not apply to a virtual version of Los Angeles, either a sort of simulation environment or some sort of virtual sci-fi entertainment metaverse version of LA. So we need all of those to occur, but we need to have different sort of policies around how those activities are managed, how authorities credential those activities, and how these various actors and assets are able to perform them. So this all gets structured into what we call a graph. A graph is a way of looking at the relationship, essentially the interrelationships and interdependencies between these different hyperspace elements that we just saw. So here's the same 12 elements. The difference is, instead of looking at the, let's call it the objects, I want you to look at the edges. The edges then are part of the framework that govern the relationship between the different elements. And so over here, you've got a user or an actor. You've got an activity that is performed by an actor. That activity applies to an asset. The asset exists in space. It exists at a time. The activity occurs in space, occurs at a time. But the activity itself, which is controlled, that actor, that user, is contingent upon having the right to perform that activity. So can that drone fly within X number of yards or feet or miles of an airport, right? Or a construction site or your home? All of this has to be able to be defined. You can define it in space, obviously, you can define it in time. And then whether or not you have that right has to basically come from an authority. So it could be the FAA, it could be the DMV, and there's a digital credential that has to be held by that user, that has to be validated by that authority, issued by that authority, that essentially enables that activity to take place. So unlike the World Wide Web today, and even the internet, where a lot of interactions are essentially just open and we put security onto it as an afterthought, this has this sort of security built into it, privacy built into it by design, by default. And essentially, it's what we call a permissioned system in a zero trust architecture. What does that mean? It's that every single interaction or transaction that happens in the spatial web can be permissioned, meaning that it has to ask for permission and it has to present that credential and that authority. And if it doesn't have it, it can't get access. And so this is very important for this next era, especially as we're talking about computing moving into the world around us, into our homes, our streets, our schools, etc. So we talked about needing new addresses. We went through domains. We talked about new ways of programming, not pages, but spaces. And we went through the hyperspace modeling language. Now we're going to talk about the protocol itself, ways of communicating and querying information through these various sort of spatial systems. So what HSTP does, Hyperspace Transaction Protocol, is it essentially enables you to query over multiple dimensions. So not just in 3 dimensions, but 4 dimensions over time, also over temperature, over motion, over pressure, over light. And so anything that you can define in the realm of physics in a computational way, and you can do it over multiple different coordinate sets, meaning it could be X, Y, Z inside this room. So if I want to know the exact location of my AirPods, this can be known because a handful of cameras are tracking it, or ultra wideband is providing information for its location, much like a GPS capability for any single object anywhere in space. But that can also reference, say, higher level coordinate systems like lat-long elevation. Finally, the bottom right corner here, we talk about multi-vectors. What that means is it's not just spatial in the sense you think of space-time traditionally. It's also about things like changing in ownership space, or money over time, or degrees of happiness, et cetera. So any sort of dimension can be both defined, can be addressed, and can be computed over, and any combination thereof. And so the query language, HSCP, essentially allows you to do that using HSML as the packet inside of it. And this is able to be exported into a language that essentially any computing system today can read. And this becomes the basis for a new generation of artificial intelligence and a new generation of data sharing, context sharing, right? The who, what, when, where, how, and why of information is context. And that context is now able to be shared between multiple devices, combining different data sources from databases and data streams into a whole new way of expressing information. And essentially what this enables is what we call computable context. And this is now not just an approximation or a near approximation that is difficult to enrich even of essentially text about the world. This can be geometrical information, it can be geopolitical information, geosocial data. So now you get a complete and coherent digital model of the world that accurately and holistically can represent these sort of spatial or physical dimensions, the semantic dimensions of meaning and culture, various social dimensions in terms of policy and rights, and at different levels, nested scales of systems, right? as well as all the data and the relationships between them. So it's a multi-dimensional way of thinking about, first just thinking about, we used to argue it's not a technological problem first, it's a logical problem. But we did solve that logical problem, and now we have solved the technological problem, which is essentially how do you make context computable across a network of applications and devices. And in a plug-and-play architecture that can be extremely open while being permissioned. What are some of the features and benefits of the spatial web? You can do things like automated regulatory compliance. You can have data and device authentication for every bit of data moving from any point to other point. All the devices, robotic systems can all be authenticated, and all those activities can be credentialed, and we can audit them in a reliable way. Secure digital transactions, multi-network interoperability across multiple different networks. You get adaptive intelligent automation, so you can have AIs that can much more easily understand the context of any sort of situation that they're provided enough data for in HSML structure. And they can then begin to automate physical real world activities. We're already deploying some of this today in a number of different applications in both supply chain and in smart city applications. And you also get geo-encoded governance. This is really important because what it allows is you have to have methods for enforcing policy for digitally mediated systems. It can't be that we let, a billion drones fly around the planet and then hopefully they don't do things that we don't like. We have to be able to actually say, here's an invisible wall you cannot pass from country A to country B. Or if you do, there's a tariff and that can be automated, right? The compliance of that can be automated. Those transactions can be automated. That drone can be authenticated, etc. So let's run through some examples of this. This gives us Internet of Things ecosystems governance at scale, right? Huge concern with these various cameras and sensors in our devices in our homes, smart homes, autonomous vehicles, now in our cities. We need to be able to ensure that both human and algorithmic bad actors cannot access these things and cannot take them over, cannot steal data from them and use them in ways that we don't want. So it's absolutely critical if we want to get the benefits of sensing systems at scale. We have to be able to know that we can control them. This gives us the power to really go to the next level with things like smart factories, where intelligent adaptation and change is able to occur in these environments. A whole digital supply chain, a relay race of moving things from manufacturing environments all the way to your home, right? So from ship to automated truck, to autonomous cars, to autonomous drone that eventually drops it off at your home. And being able to track and trace these things and even automate and adapt to various challenges. Obviously super critical. We all saw how COVID really exposed the holes in these systems. This is the nervous system of the whole planet. We need to make sure it becomes much more like the autonomic nervous system of biological creatures and less like the sort of clipboard approach to our global supply chain, our life's blood of our cities. Autonomous mobility feeds right into it. These vehicles need to talk to each other. They need to be able to share data information, location, position, kind of swarm activities, that supply chain turning into a supply network powered by distribution and mobility. Smart homes. Any of you have, I have an attempt at a smart home. I've got 8 different applications and 30 devices around the house that all barely work together. And so how smart can these smart things be if we can't get them to actually be interoperable by default? And of course, we want to make sure that the data privacy of our homes, our lives is being kept in a way that we can audit and check. That's going to be increasingly important in the future. Personal health. We're starting to wear not just Fitbits and Apple Watches, but there's all kinds of devices and headsets coming out soon from Apple and others that are tracking heart rate and galvanic skin response, and you get pupil dilation. Now, some of this is very helpful for certain applications, but it's increasingly going to be important as the data about our individual health, even looking at CRISPR and genomics and gene editing, becomes increasingly valuable to us in diagnosis and prognosis and even various therapies. And so the ability to make sure that we have some trust around who has access to that data, how we can control that data, how those devices interact with them. And now if we want to get rid of one of them, there was a great article a few years ago, who owns your Fitbit data? What happens when a company that's tracking all this information about you goes out of business? The data's gone, could have been sold to third parties. So increasingly, this is beginning to become more and more important, especially as we see HIPAA compliance and other laws around data. This will be a huge issue. And Spatial Web does solve this with this sort of data interoperability and data governance by design, by default. Clothing wearables, we talked a bit about. This is a massive emerging market, and it's going to come into smart clothing and all kinds of amazing sort of futuristic capabilities, but we need to make sure that they can easily work together and that we can control them and where the data goes. So you take this all the way up to the future is about smart cities. 70% of humans by 2050 are expected to be living in cities. These cities have to be able to take entirely new approaches to transportation and mobility and government services and automatic sort of dynamic retail, like you see the Amazon Go shop where you can walk in and grab whatever you like and walk out. Imagine that sort of Amazon Goification of everything. In the same way you get in and out of an Uber and you don't pay. Imagine if you could walk into any restaurant or any store in the city or any major city in the world, and you can just eat and shop, take whatever you want and walk out the door, and all the transactions can be automated. That sort of human experience is very similar to what we need for vehicles. Here you're seeing a scene where, this car in the bottom right here can't see that person crossing the street because its field of view is trapped. But if in fact you had cameras at all different positions with a three-dimensional representation of that space, it'd be kind of like that Blade Runner scene where he sees around the corner through a mirror what's happening in another room. These devices can share multiple perspectives simultaneously. And if you imagine them all being autonomous and moving by each other, this becomes increasingly important. So this ability to have shared context at scale is the baseline. It's kind of like how we use maps today. We can track objects and drivers and packages coming to us or people taking us to other locations in certain ways because we can rely on that same sort of underlying map. What we do is we need maps that are smarter, that have more meaning attached to them, and that have both the insides and outsides of spaces, and not just real world spaces, but even virtual spaces that both humans and machines can understand. We basically need to be able to have human context shared with machines, and that machine capabilities are things that we can easily program and control. So the spatial web enables a whole next generation of interfaces where there's secure enterprise content, access control over data sets, over interfaces, over these dashboards in the industrial and enterprise and city scale systems that they control for field and maintenance workers, et cetera. But of course, we want to know all that should be highly verifiable. The power of next generation education, right? Where you're either immersed in the environment or the content can be presented in front of you in many ways, amazing ways. You're going to see just in the next few months, as we move into 2023 here, Apple's probably first set of smart glasses coming out. And these kinds of applications are going to start to become more commonplace. They're going to replace the mobile phone apps in the same way mobile phone apps started to replace our time spent on PC programs. It's just another generation, the next turn of the dial. And whether or not you're experiencing content and information in the physical world, digital twins of real things or virtual information just presented in space, there's also us going into these virtual spaces, and the kinds of, worlds that we can explore are going to be beyond all of the, including and beyond all of the stories we've been telling ourselves from the dawn of time, the fantastical to the practical to the fantastical. And even talking about digital twins, which are digital representations driven by real-time sensor information of an object. It could be how is a motor performing on a plane, or it can be the whole planet. And so the ability to have these sort of digital twins of data at scale, and then to collaborate even from different locations. You see a person in their living room and someone else hollow into from their location, and they're both tracking data around the planet. You can imagine at scale, not just something like Wikipedia, which has been an amazing knowledge base for humanity to be able to collaborate on, but what if there was a sort of a representation of the real world, where we could look at simulations of different changes in economic systems or considerations around healthcare and others. And so this really enables global collaboration at scale, not just a sort of Google Docs, but Google Docs for anything, for any object, for any location, for any combination thereof at any scale, and in between humans and machines and AI in very powerful ways that allow a single source of truth to be verified and authenticated about any object, about the change of states of that object. Where was it? Where did it go? Where did it come from? And simulations around that. Where could it go? Where should we be taking this? And then how do we automate these things at scale? So very powerful capability. The purpose of the spatial web is not to just have this next generation network. It's that next generation network enables us to have a smarter world. The things that we expect to operate, at least at the most basic level, very well together, but that we get to operate very well together towards the kind of much larger goals that we need, because the needs have become global in nature. we're facing existential crises on multiple fronts. We've got the climate crisis, which is impacting really all of us at scale, and we're impacting it at scale. We're still in the midst of the pandemic, endemic or otherwise. It's a global health crisis, and our ability to coordinate at scale, ability to track and make sense of information, the ability to share that information and data in as close to real time as possible is going to be important for the next set of health crises and challenges that we face. And there's major social issues. And this is a byproduct of systems that have been in place for centuries, as well as economic challenges that we have around transitioning to this next generation economy. We need to find new ways and new lenses, simulation at scale, that looking at the kind of impact of our decisions. Imagine what we could have done over the last 150 years if we were able to look at the impacts of the Industrial Revolution from 150 years ago and start to model that out with any level of accuracy. Increasingly, we're going to get better and better at this with these kinds of tools, and that's part of what the spatial web enables. Really an opportunity to reconsider, rethink, and upgrade our civilization. This is part of what that Society 5.0 narrative that the Japanese have been pioneering really gets into in very great detail. And obviously, shouldn't only apply to the country of Japan. I think it's a lens that we should all be considering looking through. So just to wrap up today, kind of a burn down of some pretty major use cases. So you can apply these kinds of capabilities, the interoperability, the connectivity, the traceability, the automation, the adaptation capabilities of the spatial web. You can have applications built for smart factories that not only enable things like collaborative design and asset tracking and automated fulfillment, but also, global scale sort of fleet management and drone deliveries and automated what we call spatial contracts. So when the truck pulls up and drops off that item, it automatically charges the buyer and the seller by whatever percentage. So automating these hyperspatial contracts, if you will. Smart warehouses, same sort of thing. And in both cases, the ability to do these simulations about how to refactor or restructure or optimize the layout, and having humans and robots and machines working in tandem together. This is happening today. We're deploying applications for this that are performing incredible double-digit productivity using humans, using AI to intelligently route them through these facilities. And also getting the benefit of far less cognitive load on the workers. It's actually healthier and better for the workers, and it's more productive for the business. This could apply to smart retail, right? We talked about the ability to walk in and out, the sort of auto checkout of anything. We'd love to all have that capability, the ability for stocking people and routing people to know which way to go, and real-time sort of inventory tracking for systems to be able to do replenishment. It would be great to walk into a place, and if I wanted to have my grocery list or my dietary concerns of the month, now I'm gluten-free, that basically it just adapts that and routes me or an Instacart picker or someone else picking on my behalf through that facility, gets the stuff and drives it to my house, or a drone flies it to my house, or what have you. So total amazing, powerful changes are going to happen in retail. Smart construction, right? Ultimately, you want as designed as built, right? You want to build it as it was designed. The ability to have that, not just a blueprint in front of you, but a three-dimensional blueprint that workers can see in 3 dimensions. This screw goes exactly here, and with this much torque from its smart equipment and tools, the ability to see underground, ground-penetrating radar that's leaving 3-dimensional maps of where the gas lines are and where the electricity lines are, defining areas for where drones can and cannot fly or where they must land. Powerful capabilities, the same kind of capabilities you apply to smart mining, and then even across that whole supply chain. That sort of automated relay race we talked about, being able to not only automate the physical activities from point A to B to C to D, et cetera, but to be able to automate the transactions, the contractual obligations built into that. This is why HSTP is called Hyperspace Transaction Protocol, because it enables these events to take place where you can say, this is required and this is required. And if it's fulfilled, like any good software program, then it's succeeded. Essentially, it has passed, and you can have money move accounts just as easily as you can have an autonomous truck move from point A to point B, or a robot move from point A to point B inside a facility. Obviously, this can apply to smart oil and gas, intelligent mining, considering impact on climate, right? And having different policies and incentives built into this. Apply to smart airport, and then all these working together in these sort of future smart cities at different scales and different levels of maturity. But the power of standards and interoperability is that, provided they're running on the standards, everyone gets the benefits of that technology, regardless of implementation, provided they have the most minimal compliance. And this gets us to that ultimate sort of goal that we're looking for here, which is, can we use the power of exponential emerging technology to have real impact. So can we enable the spatial web as just this intelligent planetary scale network, which is at the end of the day is just a tool to actually impact the world? Can we make a smarter world together? Whether that's about fulfilling the UN sustainability goals, or we're running simulations on future version of what we would like the world to look like in 2050 together. This is the next level of challenges that we face. And those of us that have been looking at these challenges for a while, through the lens that it's actually possible to attempt to have a positive impact on these, I actually believe that we will have a positive impact on these. And that collectively, we're in a position to not only thwart off global crises that we're facing, we know we'll continue to deal with the human condition and human challenges probably forever. However, we also do believe that there's a massive potential, not for this sort of Black Mirror dystopic future that we're all secretly terrified about with relationship to these technologies, but a powerful white mirror future where we're able to use the best of our tools to build a world that's much smarter and works well for everybody. And so here's Jay Sammet, the former vice chairman of Deloitte, and now participant in the work that we're doing at Versus in the form of being one of our board members, saying that the impact of the spatial web will dwarf that of the internet and change how we live, work, and thrive. Why? Because it's about computing moving into the world around us, and by enabling network effects across all these different technologies, enabling their interoperability and governance, and the applications and implications of that do exceed that of the internet itself, in Jay's opinion, and I think in ours as well. Taking it one step further, and just to wrap it up, we think about these spaces, this sort of web of spaces, and these spaces being smart spaces that can be interoperable, that objects and activities and things inside can be automated, that the governance of those can be automated. But we actually think of each of these spaces as a verse, and all these various verses working together. And so sometimes people say, well, where does the name come from? It comes from the word verse, which essentially means a space with objects in it that are moving in space and time that have a certain set of laws or rules. So whether that's the universe or the metaverse or the multiverse, we would like to see that interoperability and the benefits of all these powerful technologies and applications across all of the verses. And so that brings us to our end for today. And this is why, as a company, Versus is really imagining a smarter world and building the next generation tools on top of the standards we talked about today in order to help us all to build one. If you have any more interest in the topic today, we just walked through the spatial web, I encourage you to go to Amazon, check out the book that my co-founder Dan Mapes and I wrote called The Spatial Web, How Web 3.0 Will Connect Humans, Machines, and AI to Transform the World. And I want to thank you very much for your time today.